Bismillahirrahmanirrahim. So, the last class, at the end of the last class, we discussed about centripetal force and centrifugal force. If you remember, the equations that we developed for centrifugal force at the end of the dynamics chapter was something like this. F equal to mv square by r. Okay, this was the equation to find out the centrifugal force. M is the mass, V is the velocity, R is the radius of the path. Okay, now if I replace V by omega, we know that V is equal to omega. V is linear velocity, omega is angular velocity. Then this equation will become M into omega R whole square by R. So M into omega square R square by R, and it will be equal to M omega square R. Okay, R, they will cancel each other. Only one R will be there. So M omega square R. So depending on the given information, either we will use this equation or this equation. And then at the end, we develop an expression for centrifugal acceleration. Right? Whenever there is a force, definitely there will be an acceleration. So this acceleration was equal to V square by R, or we can say omega square R. This one actually we can say from here also, as you know that F equal to ma, right? So if you compare these two equations, you will see that F equal to m, F equal to m is same. A has been replaced by V square by R. So we can from this also we can write this A equal to V square by R. Okay. Now today our main topic is to see some uses of this centripetal force and centrifugal force. Okay, especially in case of vehicle and turn of highways. Okay, come to page number 235. Okay, so number one, the motion of a cyclist in a curved path. Yes, whenever every one of you, I guess, have ride a bicycle in your life, right? So whenever we go through a curved path, we have to reduce our velocity. And one more thing happens, that we have to incline inward, or if the road is this way, then we have to incline in the left direction. If the road is this way, then we have to incline a little bit in the right direction. Now, why do we do this? Okay, inshallah, we will get to know. If I want to give you an idea beforehand, it might be like this, that to provide the centripetal force, okay, we are experiencing a centrifugal force whenever we are in motion in a curved path. So to balance that centrifugal force, we need a centripetal force which we provide by inclining inward, okay, towards the center of the curved path. When a cyclist or a runner takes a turn, he has to incline his body along with the cycle or his body towards the center of the circular path, right? You understand this, right? If the road is like this, okay, the center will be in this direction, so a rider has to incline in this direction, okay? Now why? If he wants to take the turn keeping his body straight, he may skid, okay? He may fall out of the road. Okay. To pedal the cycle in a circular path, the centripetal force along the horizontal towards the center of the circular path is required. This is what I was talking about. A centrifugal force will be acting on anybody who is traveling through this curved path. Now, to balance that, we need to provide a centripetal force. Okay. Okay. If mass of the cycle along the cyclist is m, and to pedal his cycle in a circular path of radius r, okay, the radius from the center, the radius of this path is r, with uniform speed v, the velocity with which the cyclist is running his cycle or riding his cycle is v. The centripetal force required to the cyclist is F equal to mv square by r. That one we already discussed, right? The amount of force that he needs to provide or he needs to create a centripetal force is mv square by r. When a cyclist pedals his cycle two forces are applied on it. Okay, before we actually discuss about this further, I want you to realize something. Okay, now from the equation we get to know that F is equal to mv square by r. Now what does this tell you? What is the relation between the force and the mass? If I say that V and R are constant, then the relationship will be proportional. That means if a heavier object or heavier vehicle is taking this turn, the centripetal force required to keep it on the road will be higher, right? That means if the mass is doubled, force will also be doubled. Also, it will be doubled. Okay. Now, what is the relationship with velocity? If you look at it, F is proportional to V square. That means if you double the velocity, you have to quadruple the force, okay, because it is proportional to the square. So if you double or twice, make the velocity twice, then the force has to become 4 times. If the velocity becomes thrice, the force needs to become 9 times. These are important for MCQs also, okay. Try to realize. And what is the relationship with this radius? F is inversely proportional to the radius. That means as the radius increases, the force decreases, the less amount of force you need, right? If you think about it in this way, if the radius is small, then what will happen? It will be more curvy, right? The radius is small, but if the radius is bigger, okay, let us say the radius is bigger, then you can see that the road is a little bit less curvy, right? The bigger the radius, the lesser the curvy the road is. Do you understand my point? So if the road is less curvy, then what will happen? No need to produce that much of centripetal force, right? It will be easier for us to actually stay on the road. When it is very curvy, means the radius is small or the circle is very small, then we need to actually make a very good turn to stay on the road. And as a result, I need to provide a stronger centripetal force. Do you understand this? The relationship between the radius of the road and the centripetal force that needs to be generated?
Yes.
Okay. So
Yes.
these are important for MCQ and also for solving creative questions. Okay. Do not just go on memorizing. Try to realize what does it say. Okay, and try to match it with your practical experiences. And learning will be much more easier, interesting, and solving the cases also will become easier for you. Achha. Now, when a cyclist pedals his cycle, two forces are applied on it. Right. Number one, the weight of the cycle along with the cyclist in figure 4.21a. In the figure, next page, 4.21, there are two figures are given. Okay. In the first one, you can see a boy is riding a cycle, but he is a little bit inclined. He is not straight. Why? Because he is going through a curvy road. Okay, so as a result, what is happening? He has to incline inward, okay, or towards the center of the road. So number one force that is working on him is the weight. Definitely, he is exerting a force in the downward direction, right? The weight of the cycle along with the cyclist, yes, both combined, vertically downward, and the ground reaction R. Whenever you actually stand on the ground, you are applying a force that is equal to your weight on the ground, and the ground is giving a reaction force according to Newton's third law. So opposite to the direction along which the cyclist applies force to the ground, right? Okay, now he is to manage the required centripetal force from the above two forces. Two forces are acting. So from these two forces, he has to manage this centripetal force. Okay. Now, as you can see, the second figure, it will actually make your doubt clear. The weight acts vertically in the downward direction. That is, W is equal to mg, mass into acceleration due to gravity. Now, as he is in inclined position, the reaction force that he will get will be in this direction. Okay, weight always acts vertically downward, but the reaction, how the reaction force you will get, it depends on at which angle you are providing the force. If you are just standing straight on the ground, then what will happen? You are providing the weight force straight vertically downward, and you're getting the reaction force also vertically downward, and they are balancing each other. But what happens in this case, as he's not riding the bike straight, rather he's driving it at an angle, what will happen? He will get the reaction force at this angle. And this reaction force can be resolved into two perpendicular components, as we learned in vector chapter. One, if this angle is theta, then it will be r cos theta, and this will be r sin theta. Now this r sin theta will be balancing W or the weight. Okay, they will be balancing each other as they're acting on the same point in the opposite direction. So they will be balancing each other, and they're equal to each other obviously. Now there is an extra force remaining, that is r cos theta. That will actually provide you the centripetal force that you require. Understood? Okay, this will provide you the centripetal force. Now think about it in this way: if he was riding straight, the action reaction force would have been in the straight line only. No force would have been generated towards the center of the road, right? Now, as he is inclined a little bit, he is getting the reaction force at an angle with the ground, and that can be resolved in two perpendicular components. Out of these two, one is being used to balance the weight, and the other one is serving the purpose of centripetal force. Do you understand why we have to incline towards the center? Okay. As this is the centripetal force, this will be equal to F and equal to mv square by r. Anybody have any doubt? Do you have any doubt? Understood why this is going to be the centripetal force? If you have any question, you may ask me now.
Sir, I didn't understood why we will take r cos theta.
R cos theta. Did you study the vector chapter? In vector chapter,
Yes.
actually, we studied resolution of a vector. So if I have a vector, I can resolve it into two perpendicular components. See, this is one component, this is one component, and they are perpendicular to each other. So these are two perpendicular components. Now, with one of the component, I have taken the angle theta. So if I have taken angle theta with this component, then this will be r cos theta. This one we actually studied already, if you remember, in vector. If you want, I can actually forward you the video that I took class on this resolution of vector chapter. Okay.
Okay.
Okay. Kindly go through that, and inshallah it will be clear. It is very easy. You know that trigonometric ratio thing, right? See, okay, so this is r, and I'm resolving this into two perpendicular components. Let us say this is theta. Okay, let us say this is the x component and this is the y component. Now this, if this is y, this is also going to be y. Correct or not?
Yes.
Okay. Now, if I want to find out the value of x or what the value of this component, then how can I do this? I can take, see, for this theta, this is adjacent and r is hypo. So adjacent by hypo, this becomes actually cos theta. Cos theta is equal to x adjacent by hypotenuse, that means r. So if I cross multiply, x will be equal to r cos theta. Right? So this x I
Yes,
can
sir.
replace by r cos theta now. And if I want this one, then see, for theta, this is opposite and r is hypotenuse. So oppo by hypo, that actually gives us sin theta. So sin theta is equal to opposite by hypotenuse, and if you cross multiply, it will be y is equal to r sin theta. Here I have discussed in a shortest
Yes,
possible way. I have discussed this
I
elaborately
remember
in another
now.
video. Okay, so if you want, you can see that. If you need the link, you may message me, I can give you. Okay, so this is the way to resolve a vector into two perpendicular components. Okay, now are the rest of the things clear, that why this one will be balancing the weight and why this one will act as the centripetal force? These things are clear. If there is any doubt, you may let me know. If you do not let me know, then I cannot discuss. Either you have to say, yes, sir, we understood, you can move on. Or you have to say, no, sir, I didn't understand, please repeat. If you stay silent, then the class time is going to be killed. And it will be your loss, not mine. Please speak up if you have any doubt.
No, no, sir.
Okay, so here in this figure, I have considered this one to be theta. That is why this one is r cos theta. But in your book, they have considered this angle to be theta. If this angle is theta, then this one will become r cos theta and this will become r sin theta. It's up to you, no problem. Now from here, I can write two equations. That r cos theta, it will be balancing the w, that is the weight. So r cos theta is equal to mg. And r sin theta is equal to mv square by r. So I can consider this one as equation 1, this one as equation 2. So if I divide equation 2 by equation 1, then what will happen? R sin theta divided by r cos theta, and it will be equal to m d square by r divided by m g. So r and r, they will cancel each other. Sin theta by cos theta will become tan theta is equal to m and m. They will be cancelling each other. So it will become d square divided by rg. So this equation is very important. Why? Because through this equation, we can actually calculate that what angle the cyclist needs to incline in order to stay on the path with a given velocity and radius of the path. Okay, you have to know that at what velocity you want to go, and you have to know that what is the radius of the curved path. If you know these two parameters, then I can tell you, or you can calculate yourself, that what angle he needs to incline. If the velocity is higher, then he will be in need to incline more. Okay, if the velocity is less, then less inclination is okay. Okay, so it is important to consider this angle to be theta, because from here I am inclining at a certain angle. So this angle is important to me. So tan theta is equal to v square by r. Okay, is it clear?
Yes.
Okay. So the second one, banking on a road or a rail track. Now, why the same topic is being discussed again? Okay, because whenever you are riding a bicycle, okay, it is easy to incline yourself, right? No problem, and you can generate the centripetal force. But what about when you're riding a car? Can you incline your car towards the center of the path? The stuntsmen, those who do it in the movie, they may do it. But for us, normal people, it is not
We
easy.
cannot do.
We cannot do like that. Okay, we cannot incline our car. Okay, we cannot. We have to drive actually straight. We cannot make our car incline like this to produce a centripetal force. So in such case, what we need to do, considering this situation, those who prepare the road, they actually make the road already a little bit inclined whenever the curvy parts come. If it is a straight road, then it is okay. But when the road is a little bit curvy, then what happens? This outer side, this is the inner side. If the road is turning this way, then this is the inner side, this is the outer side. The outer side becomes, or they keep it a little bit higher, so that the car that passes through this road is already a little bit inclined whenever it is passing. Why it is important to incline? Because they need to provide the centripetal force. Again, I'm saying the same thing. Do you understand? Now, what happens is, generally the road remains like this, but whenever there is a curvy path, the outer surface is taken a little bit up. So we have to go like this, okay? So that makes an angle with the horizontal, right? This angle is called banking angle, or banking of the road. Okay, this inclination with the horizontal is called banking of the road. Now we are going to study in details about this. Banking in a road or a rail track. When a motor car or a train has to take a turn, a centripetal force is required. Always, whenever you are taking a turn, a centripetal force is required to move it in a curved path. If this centripetal force is not available, then due to inertia of motion, the car or the train will go along the tangent of the curved path. Sometimes the vehicle may topple down out of the road. Okay. When a vehicle has to take a turn on a plane means not aeroplane, on a plane, on a road, okay, on a surface. The centripetal force is supplied by the frictional force between the wheel and the vehicle and the road, but the value of the frictional force is being very small. Okay, the frictional force is there, but it is not enough to keep the car on the road. Okay. Acha, being very small, the vehicle cannot take turn very fast. Yes, if there is no banking, then you can take turn, but the velocity has to be very slow, okay, very low. If it has to take turn very fast, the amount of frictional force has to be increased. And for this reason, at the point of turn, the plane of the road is made inclined with the horizontal so that the outer side of the road is a bit higher. See, outer side of the road is a bit higher, okay, than the inner side. This is called banking. The angle produced by the two sides of the road with the horizontal is called angle of banking, which I already showed here. This is the angle of banking. We express it as theta. Okay. From figure 4.22, it is seen that the weight of the vehicle W is acting vertically downward. Yes, always the weight acts vertically downward. Even though the body is a little bit inclined position, the weight will always act vertically downward. Remember this. Take a look at figure 4.22, please. Okay. Now let the weight of the vehicle along with the passenger is W. अच्छा, আমি figure দেখতে জানি। From now on, whenever actually pass through a curvy road, okay, or you are taking a turn, try to feel or try to observe how the road is. You will always feel that the outer side is a little bit higher and you are a little bit inclined. You will see that, okay? So if the vehicle is here, okay, actually from this figure you might feel like the vehicle is going down like this. No, this is the back side of the vehicle. This is the road and the vehicle is going in the front direction. Okay, this is the back side. I don't know how to represent it. I'm very bad at it. Maybe if I show the tire like this, then you will understand or something. I don't know. Just try to imagine that it is going in the front direction. Okay. Achha. Now, so the weight is acting vertically downward. So from here, I will show the weight W is acting in vertically downward direction. Then what we have, it is in the weight of the, yes, and there will be a reaction force, okay, that is Fn acting on the vehicle perpendicular to the road. Yes, as this is inclined, okay, the reaction force actually acts perpendicular to the road. See, this is the road, it, perpendicular to it, the reaction force Fn will act, okay. The reaction force always acts perpendicular to the road. Okay, the resultant of these two forces F acts towards the center of the horizontal circular path. Now there are two forces, right? Okay, so whenever there is two vector, I can always find out the resultant of these two vector, right? And I can easily imagine that the resultant will be along this direction, okay, in the middle, okay, and that they have mentioned as F. Then this resultant force applies the required centripetal force to move the vehicle in the circular path. Yes, this is the centripetal force. Now, F by W is tan theta. We already know this, right? F by W is tan theta. From the figure also we can actually understand this. If you think about it in this way, wait, the figure actually in the book it is wrong. Okay, so that is why we have to draw it correctly. But let us just observe the situation first. Achha. So as you can see, we have got a right angle triangle here, and this angle is theta. For this angle theta, this is the opposite, and this is the adjacent, right? The opposite to 90 degree, this is the hypotenuse. Now we are dealing with the opposite and adjacent. And opposite and adjacent, these two actually make the trigonometric ratio tan theta. So that is why tan theta is equal to oppo, that is F, divided by adjacent, that is W. Okay. Now if you cross multiply, F will be equal to W tan theta. W can be replaced by mg because this is the weight. Now again, this F, I said that this is going to serve as centripetal force. So if it is centripetal force, we can replace this F by mv square by r. So in this equation, if I replace the F by mv square by r, mm will get cancelled, and this G is multiplied here. So if I change the sign, it will be divided. So tan theta will be equal to v square by rg. This is the same equation that we got in case of the cyclist, if you remember. Okay. So using this equation, we can actually find out the angle of banking that is required, okay, for a given velocity and the radius of the curved path. Okay. Now sometimes different set of values might be given. Okay. Now based on that, we need to calculate the angle of banking. How? Let us see. Take a look at figure 4.23. Okay. In this, you can see that this is the banking of the road. Even though the road is not actually inclined at such a bigger angle, but for your convenience, I'm drawing this to a larger scale. Generally, this angle is very small. It's very small angle. So this B is the width of the road. This is the width of the road, okay? And this is height from the horizontal from the horizontal level. This is the height of the outer surface. Okay. Now, from here, what we can write, if I want to relate this h with this d and theta, then what I can write for this theta, this is opposite and this is hypotenuse, right? Because this is 90 degree, opposite to 90 degree is hypotenuse. So, oppo by hypo, they can be related by sine theta. Oppo by hypo. So, from here, if you know any of the two values, let us say width of the road and the angle of banking, then you can tell that the outer surface is how much higher than the inner surface. Okay. So, or else if the height is given and the angle is given, you can find out the width of the road. Okay. Out of these three, any two will be given and you can find the rest one. Okay. So today, inshallah, we will finish our class here and tomorrow we will start from collision. Okay. Inshallah, that will be our last class of this chapter. Okay. So before I end the class, anybody wants to ask any question? And as I requested, I hope you all have started solving the creatives from the suggestion book, right? From the PDF. Okay. Did you download the PDF? Shiham, kindly download the PDF and give it in the group. Okay. Can you do that?
Yes, sir.
Okay. Thank you very much. See you all in the next class. Assalamu alaikum warahmatullahi wabarakatuh.